All right. Welcome to PyCon 2022. Let's see, how many of you are first-timers to PyCon? Whoa, nice. Guess I'm not the only one then. This is my first PyCon. How about first time at any conference whatsoever? Yeah, there's a couple of us. This is my first conference as well, so it's really cool. I'm super excited. I want to give a great big thanks to the Python Software Foundation, who invited me to come to speak today, to share this tutorial with you. If you're here, you probably signed up for this tutorial or got lost in one of the hallways over there. Either way, I'm super excited that you made it. And the name of this tutorial is, no, not Hello World. Let's say goodbye, Hello World, and let's say hello to our functional FastAPI web application. All right, so I'm going to give you a little background. My name is Mario. I graduated with an English major and worked at a nonprofit as an editor for a couple of years, and I naturally transitioned into payroll, and I worked in payroll for about a decade. In between that time, I've done some odd jobs. I coached high school soccer. I've written, produced some music on the side. I freelanced writing different odd jobs. And I actually didn't write a line of Python code until late 2018, which was about 3.5 years ago or so. You'll see that's an email I sent to a friend with the subject line, "for fun." I was super excited. That's my very first Hello World script. I was excited, 3.5 years ago. So you may be wondering, what's this guy doing up there? Well, I've had an off-again, on-again sort of relationship with Python. I got in, I just went, I dove right in. I started doing machine learning stuff, cleaning data, web scraping, some natural language processing, and I wanted to build this really cool application using sentiment analysis and serve it up through some sort of application, but I really didn't know what I was doing. So I think I bit off more than I could chew. I stepped back, I stopped for a little bit, and then about a year ago, I decided to kind of step back, start from scratch, learn how to actually build an application, and I focused on the web side. I thought, hey, let me see what it would take to go beyond some tutorial. And what you didn't hear in any of that description of myself, I'm not a developer or software engineer by trade. It's all what I do at night. My application eventually became a blog titled Python by Night, which is, again, just something I do on the side, not during my day job. About 2 years ago, I started working in tech as a business analyst, so maybe I'm just creeping up that way. But I can add some value to those of you that are here today. I know what it's like to be stuck in that kind of beginner phase, not quite sure knowing where to go next, specifically when it comes to building a web application. And I know how difficult or daunting it can feel to build something from the ground up. And I like to immerse myself in what I'm doing. Some of you may be way more advanced in your Python knowledge, but you may be wondering, well, how do I take that knowledge and apply it to building a useful web application? And so I hope that I can help you out here, and maybe you'll help me out during the tutorial. You can be my code reviewers. All right, some of the things we're going to cover today. We're going to start off our keyboards just talking about complexity. How do you approach something that's complex, that's difficult, that's daunting? How do I build a web app? What are the thought processes, and how do we move forward? Then, after that, we're going to talk about the skeleton of your framework. Is the application structure. It's what really holds up what we will be building. We'll move into configuration. These are all the buttons and levers that determine your app behavior, that really move it along to do the things it needs to do. Very important part. We're going to spend quite a bit of time with our configuration. We're going to connect to a database. We're going to make an actual connection to a MongoDB database. Some of you who may have done the extra credit might have a local instance or an Atlas account. You'll be able to connect to either one of those. And we'll then talk about the app behavior, and this is where you will have something to put your ideas and develop them all the way. This talk is divided in 6 parts. These are the 6 sections we're going to cover. After the 3rd section there on configuration, we're going to take a short 10, 15-minute break depending on how we're doing with time. We have a lot to cover, so I might be moving a little quickly, but hopefully we have time for interaction, for questions, and by the end of this talk, you will have a working web application that is ready for your ideas. And I just, one thing I've taken for granted, and I talked to a couple guys actually who are here taking this class earlier, and one thing that I've taken for granted is when we say the word web application, it might mean a lot of different things to a lot of different people. Some people focus on just an API, that's all a web application is, or is it a spa app that does a whole bunch of things on and offline? I'll talk a little bit more about that, but you will have a working web application by the end of this course. You will have an extensible configuration system that allows for future growth, that's easy to read and maintain, and you will be connected or have the ability to connect to a database, a MongoDB database. If you choose a separate or a different database design, it shouldn't be too difficult to just take what we've learned today and attach it to another SQL or NoSQL database. And then we'll be ready for your ideas. You should be able to leave here with tons of things you want to do with this application that you'll be able to serve up to the web. Now, prior to submitting my proposal to the PSF, I was working on a GitHub repository. It's a little on the nose, useful web app. I wasn't thinking I'd be presenting. I was just putting down all these ideas. Much of what we cover today is already up there, although it's a little outdated. I think my last commit was in March. I will give you some resources after the talk, so you don't have to write it down right now. And I think that's my intro. Do we have any questions so far? Everyone feeling pretty good? All right, sounds great. So this tutorial session is going to be anchored on 3 pillars that I think are just fantastic libraries. The first one is Pydantic. Much of FastAPI is built on top of Pydantic. If you're not very familiar, I would encourage you to just put it into almost anything you would do that involves data validation or serialization. It's a great library. And to connect to our MongoDB instance, we're going to use a library called Beanie. It's also built on top of Pydantic, the same way that FastAPI is built on top of Pydantic. It all just works very cohesively, and you'll see how and why as we get on with our presentation. All right, we're going to dive right into the first section. We won't need our keyboards here. We're just going to talk a little bit through this. If you have any questions, please raise your hand. I'm happy if you interrupt me. I just want to make sure everyone is on the same page. All right, complexity. Sometimes some tasks might seem difficult to approach. How do we build a web application? The first thing I thought of, okay, let me choose a good web framework. So I went online and I typed web framework in Python, and I was like, oh, okay, that looks pretty good. Anyone well, that one's pretty simple. You know what that one is. I can barely see that one. That's Flask. Anyone know what this one is here? Anyone? This is Pyramid. This one's kind of self-explanatory. Anyone familiar with this one? Actually, this one's not that well known. This is Falcon. I think we had 1 or 2 users of, does anyone know this one? Tornado, that's right. And we have AIO HTTP, and maybe this one's really hard. No, just kidding, it's called Cherry Pie. And of course, FastAPI, and there's a lot of newer libraries. FastAPI itself is built on top of a web framework, Starlet. There's a newer one I'd like to try out called Espresso. Tons of choice. So you have a paradox of choice. There's so many choices that you just don't know where to start, and you might think, well, maybe this isn't for me. And even if you choose a framework, what database do I use? Do I use Postgres like everyone else, or MySQL, or should I use MongoDB or some other document-based database? And then once you've got all of that, then you have to worry about deployment. How do I do that? So it just piles on top of itself. So the first problem is that there's just too many choices, and it's kind of hard to move forward when you're in that stage of paralysis. Now, my suggestion for this is kind of on the nose too. Just choose. You almost can't go wrong with any of the libraries that are out there. Most of these projects have excellent documentation. They have open source maintainers, and they have source code freely available for everyone to look at in GitHub or any of the other repositories. You can type in through search to even see other projects that are using these libraries and get a few examples. I think that's, to me, that was amazing when I could just look into the source code for something like FastAPI. I may not know what the heck is going on in there, but little by little, as I immerse myself, it really helps on building my own application. So just choose, and those of you that are here, you're on the right direction. But one thing can happen when there's a lot of choices is you might get a little bit of what's called FOMO. That's the fear of missing out, right? You start something and you're like, well, I kind of like this, but I started hearing about this other library that I'd really like to use, or it doesn't quite work well with this database model. Like, I wanted to use Mongo and it doesn't fit well with this library. So that can become a big problem, and then you just say, well, this doesn't fit my needs, so I'm just gonna work on something else. And that's not a bad idea. Just scrap it, start again. Most of us who are working through these situations, we're not under some deadline pressure to get something done. We're trying to learn something new. It's okay to switch. How I started Python by night, for example, is I just wanted to learn how to build an application. So I booted up Flask, and I had a local instance of PostgreSQL running on my machine. And I think I even might have deployed a version of it to DigitalOcean, and it was working almost to the point that I thought that was my solution, but then I must have heard, I think it might have been Python Bytes or some other podcast about FastAPI and about MongoDB, and I just thought it was really cool. And I just thought, how hard could it be to just start over? And so I did. And so now the site that I have online is built with FastAPI and MongoDB. So first of all, just choose something, but if it's not working for you, just choose something else. It's okay to switch. As a matter of fact, the refactoring itself will help you as you continue learning about frameworks in general. Now, there's one more problem I'd like to talk about, which is you've got the tools you're going to use, you're ready to go, you sit down and write your first Hello World application. It was really easy, but then you're not quite sure what to do next. So then you're wondering, what resources do I use? Should I just go on some random Stack Overflow question about some little random thing and try to figure it out? I don't think it's a bad idea. Up to this point here, where standing in front of you, I haven't paid for any course or taking any class that has to do with Python. Everything I've learned has been just through my search engine and random people asking the same question online. There's awesome tutorials, there's websites, YouTube videos, Twitter. Twitter can be a great resource. You can ask people directly on Twitter, which I think is pretty great. And there's some great websites like RealPython, TestDriven.io, or Free Code Camp. All those have excellent resources to get you going. And of course, you're here, which means that if you are looking for something a little more direct, you can pay to learn in a more focused, structured manner. And I think that is also a great avenue. Not only are there tutorials like this one, but there are great trainings online. There's, I have looked at and haven't taken yet, but might take some TalkPython.fm trainings. That's like a subscription-based training site that gives you access to a ton of trainings for life. You don't have to buy them individual. And you have testdriven.io, I believe. So don't discount those as well. Once you have all that, and you're wondering, now, how do I take all of this and apply it? Some of these things are common sense, is you want to start breaking things down to the smallest pieces. You may not know how to build a web application, but you may know how to write a function, if you may not know how to build a full database operation solution, but you might know how to build one function that knows how to read something from a database. Just start thinking smaller. Break things down and learn by immersion. Just let yourself kind of be consumed by all the info that is out there, but learn how to focus. And then, of course, you want to ask questions. Now, you've heard there's no such thing as a stupid question, and that is true. It acknowledges that our search for knowledge includes failure. So, it might seem like a stupid question. You're like, should I ask? Yes, go ahead and ask. We have all been there. We've all asked the wrong question. But also recognize that asking questions is also a skill. It's a skill that you can develop and that you can become better at. How many of you have heard of the XY problem? Has anyone here heard of the XY problem? Yeah, we have one person back there who's heard of the XY problem. I hadn't heard about it, but I know I had that problem every once in a while. There's this website called xy.info. It's just an informational static site there about what the XY problem is. It talks about the XY problem being when you ask about an attempted solution rather than your actual problem. The problem occurs when people kind of get stuck on what they believe is going to be the solution to their problem instead of the actual problem. That again is from the website. So for example, let's just do a little exercise. If I were to ask you, how do I remove the last 3 characters from a string in Python? How many of you know how to do that? Some of you, right? What would be one way to do it? Is it a term? You may have heard of slicing, for example. You can treat the string as a list and then do a bracket, bracket colon, and then -3, which means 3 characters back. All right, so you know what? I feel like I was going to demonstrate this on the REPL, but I think I actually want to get moving to our next section. Mostly, what ends up happening is you can ask that question, go on Stack Overflow, maybe someone tells you, and you go and you test it, and it feels really good. But then what you realize is all you really wanted to do was go into a directory and remove the extensions of all your file names so that you could get just the name of the file. So if you're looking at all your .py files, then you're in luck because it's going to remove the .py and you're going to have the name of your files. But let's say for some reason you were going through your directories and you realized, oops, I have an HTML directory and I have an index.html. Now you have a string that says index.h, and that's no good. What are you going to do with that? So you may have just asked the wrong question. There's an easier way to do this with the awesome pathlib library. You would just use path instead and feed it the directories, like you see here, a file, index.html. If you print out the stem of that file, it doesn't matter how many characters exist after the period. In this case, if you print the stem of a file, it will give you index, whether it's index.htm or index.html or index.html, xyz, abc. It'll still give you index. And so had I learned to ask the question correctly to begin with, which is, how do I get the string value of a file, or how do I remove the extension of a file name, might have been a better question. So this is just a way to recognize in your own coding ways that we can start going down the rabbit hole. You think you have the idea of how to do it. But then you're not sure how to do that, so you ask a question on how to do that, and it just kind of can devolve, and it can have multi-layers if you see what I mean by that. So to recap, for my recaps, I'm usually going to have 3 points, 3 takeaways. Hopefully it kind of helps some of this set in. Let's make sure you start somewhere. Choose. Those of you that are here, I think you've already gone to that. You've already chosen. It's okay to switch if this tutorial isn't working for you, if what you're building today isn't working for you. Feel free to switch. It's going to be great. You won't have lost anything. You will only have gained. And learn to ask the right questions. Don't be afraid to ask the question. If all you know to ask is how do I remove the last 3 characters of a string, then go ahead and ask that question. But start thinking deeper about the things you're asking, the solutions you're looking for as you're building more complex applications. All right, now we're finally going to start getting into our computers. Most of you are like, phew, let's get moving. We're going to start talking about app structure now. Let's say I were just to ask for what kinds of things might be needed to build a web application. What might you say? What might be some things we might need in our application? Any idea? Go ahead. I think I'll have to say it for you. Anyone? Yeah, so a framework. And what's going to be like, so you're going to have a framework, and this framework is going to have to take care of the things that exist in an application. So what kinds of things might exist? A data source, what was that? Yeah, like a database. I think a database is pretty, is one of the main ones. Yes? Sorry? A front end, that's correct, a front end, yes. Routing, excellent. Yeah, those are all great things. Now you're starting to think, and these are some of the questions you should start thinking about almost before you start working. You start thinking about what are the pieces I need. I'm definitely going to need storage of some sort, database, routing, what to do with the endpoints, front end. Like once we have our application doing something, then it's no good if you can't actually go on the web and use it, right? So there are different, of course, some of them might be pretty simple. If, let's say you have an API, there might not necessarily be a front end in a traditional sense, like if you're having a web page, but still it's something to think about. You're still having to add logic to certain routes. So yeah, those are all great. Now, as you start thinking of those pieces and you start building them up, it starts building some sort of shape. And I'm not going to spend a lot of time here talking about what way to approach application structure as far as a layout. I think there might be some that you've heard about. Of course, might be the person that's just throwing modules into the same folder, and you have a bunch of modules, your models, your routes, your everything all in one flat file. For something simple, it might work for you. Some of you may have heard of the model controller view, the MCV. I encourage you to look up these things or not. I think what tends to happen is these are one of those things that can get you going down a path and get you stuck. Domain-driven design is something I've learned about recently, which I thought sounds really great. And I think really, though, when you're starting out, the best advice I would give is first start creating a mental model of what you want your application to do. Start thinking of those things we were talking about, those pieces, and how you might put them in a directory structure. We've all worked with directories already. We all know how to organize our own files. For example, some of you who like a flat file design might have 1 million icons on your desktop, whereas some of you are very neat and have dates and really nice full directory structure that you use personally. Ultimately, I think the more organized you are in terms of how your brain thinks is what's going to lead you to a good design. And then you'll find that you'll actually start edging towards some of those types of application structures that we were talking about. You might find the MCV starts making more sense after you've gone through the process of building your own structure. So Now, we're going to start creating an application structure. It's going to look a little like this. You don't have to do this just yet. We're going to do it together. But just to give you an idea of what our project structure is going to look like, we're going to have a project root, any name you choose. For me, I just called it GHW, Goodbye Hello World. And then underneath our project root, I'm going to have an app directory. It's typically called app or source, or it can be whatever you want. It's used within your code, so I think app makes sense. When you're doing imports, you're going to go to the root directory, which is going to be app. And main.py, that's usually where you see your first hello world script, right? That's where the app creation happens. And the init.py, that's what makes this a package. We don't have to write any code in there. The next 5 directories there we're going to deal with in some way. We're going to talk through them. Core, CRUD, DB, models, and routes. I'll talk a little bit more about those in a little bit. I am sadly not going to be talking about tests in this presentation, though I encourage everyone to test their software or their application. I lied. I bought my first Python book shortly before coming to PyCon. It's on PyTest, the Brian Ocken book on, on testing, because that's a place where I'm kind of lacking. But very important. So I just created a directory there. That's going to be for you to fill. And then we have a .venv. I use the dot notation because of VS Code. It's a hidden file. You can use .venv or just venv. I have a .env file. That one is for our secrets. We'll talk a little bit more about that. And then a gitignore. That's used in version control. I encourage you all to learn that as well. Again, not something we're going to cover. And then our dependencies are going to be in a requirements.txt file. All right, so let's go ahead and get our project root started. I have used PowerShell from time to time. I've just started using stuff in the terminal. Some of you may be using Bash, so the commands might be a little different than PowerShell. But we're going to go ahead and create a directory, our project root directory, name it whatever you want, change into that directory, and then when you're in that directory, create a directory for your app and your test. That comma there is used in PowerShell. You might not need that if you're using Bash. Or if you like the GUI, you can do this in your, you can do this through your File Explorer, so you can do it that way as well. So you should have, what you see here in the bottom is a project root and app and tests. Okay. And then what we're going to do is, if you're still in the terminal, we're going to go ahead and create our virtual environment. Oops, I meant to go down. Now, I use PyLauncher. If you have Windows and you use PyLauncher, you may just need to use Py-M. If you have a MacBook, you may need to use Python 3. I'm not familiar as much with the Apple ecosystem at this moment. And then after you create your virtual environment, go ahead and activate it. If you don't activate it now, it's okay. We're going to transition to using our IDE in a little bit, but I just kind of want to make sure you get a general feel of what's going on. And then after you've done that, we're going to change into our app directory, cd app. And then we're going to create the 5 folders that we talked about, the 5 directories we talked about earlier. So the first one is core. That one's going to house, and if it's a little hard to see in the back, I'll just speak through these. We have core, which is going to have most of our app logic. CRUD, which is going to handle the logic for database operations, most of the logic of our application. The DB directory I use specifically for configuring my database. I'd like to keep it separate from our configuration. Our configuration file will live in the core directory, but I like to keep the DB configuration separate in case you want to do migrations or change things around from one to another. The models directory is next, and then after that we have a routes directory, which will handle our endpoints. Now, if you want to go ahead and get your text editor or your IDE open, I like to use VS Code. Some of you might use PyCharms. Either way, you want to open it at the project root level. So if you're on VS Code and you're going to open, I like to use the open file or open folder option. I would navigate to my project root, and I will go ahead and get it open. Let me. So if you're in VS Code, it might, let's see if I can actually, that's hard to see also. App directory, core, CRUD, DB, models, routes. And then what I want you to do under the project root, so you would want to make sure, I have called this one GHW1. If you're in the project root, I want you to go ahead and create these 3 files. There's a .env, so it is a file that starts with a dot, and .gitignore, and a requirements.txt. Let's see if I can. Yeah, forgot I had that here. All right. Now I know we talked about the 3 pillars. We're going to have 2 more files that we're going to put into our requirements.txt. I like to use FastAPI, and then the Pydantic has brackets, and in between the brackets it says .env, and I'll explain that a little bit later, and Beanie. So those are our 3 pillars. We want to go ahead and add those to the requirements.txt, and then we're also going to add these 2 down here. They're necessary for different reasons. The unicorn requirement is so that we can run a local, yes, sir?
Hey, is it possible to get this slideshow set out so we can follow along? We're just having a hard time seeing that.
Gotcha. You know what I'll do? If you go to pycon.pythonbynight.com, I believe my latest version of the slides should be up there. And you can follow along. If you hit the F button when you get there, it actually goes to full screen so that you can see it a little bigger. But you'll just have to catch up. If you hit the right arrow on your keyboard, it'll cycle through so that you have access to it. So let me actually put it up here. It is pycon.pythonbynight.com. And let's see if I can. Let me make sure I have that as well. Say again? Where did I feel like so yeah, that's what it should look like when you get there. Is anyone not there still? All right, so let me see if I can, yeah, I'm gonna write it down right now, just 1 second. So it's pycon.python. Should be like that. No www if you were putting that in. Again, it's just a copy of the slides that I'm going through, so especially for those of you in the back, it could be useful. And also, I believe, as we get closer to doing actual code, you can also use the same website with a trailing /examples, and the full files that we'll be working on are on there as well. But for now, you're going to want to be following along with the slide presentation. All right, anyone still having issues? Blank screen? Okay. So it might be on my end. Oh, yeah. So that's right. So when you're there, if there's a blank screen, what's happening is it's the start of the slideshow. So just hit your right arrow, or there's a little button on the side that you can click as well, and it goes through. I apologize for that. Oops. All right, anyone else? Okay. All right, so if you've got the requirements.txt, there's 5 libraries in there. Go ahead and pip install. I like to, okay, if you have activated your virtual environment, this is when you would pip install. You would probably need to activate it within your IDE if you haven't already. It's one of the things that can confuse a lot of us. Once you have your project set up, say, in VS Code or PyCharms, you're going to want to make sure it's using the virtual environment that we created. So just make sure that it's activated from within your IDE, and then run the pip install. I like to precede my pip installs with Python-M. It makes sure that it's using the correct one. So the first 3 are FastAPI, and then Pydantic. Oh, here, let me do this. There you go. Pydantic, and then in brackets it says .env or .env. And the next one is Beanie. All right. So UVicorn, again, it's so that we can run our FastAPI application locally, or that's basically the server, ASCII server. And then PyMongo, in brackets, you have SRV. PyMongo actually comes with Beanie, but you need the SRV extension for connecting to the Atlas account. So that's why we're adding it here. Okay, I am going to keep going. So that concludes our app structure. We've got our skeleton that we're gonna work with. Again, hopefully what we're doing here fits a type of mental model that can help you separate the concerns of what we will be working with. Again, this is a suggestion, and if you're following along, that's great. Or you just kind of may be immersing yourself and something else might work for you. That's good as well. What we want to do is create a skeleton. I like to get a basic idea of what my app will look like when it's done. That's why I like going through this exercise of just thinking, here are the things that I'm going to need to do with this application. Most of them might mimic something like this, or they might have a lot more complexity to it. But as long as you understand what is what. And then the main thing that we want to do is make sure that we're separating the concerns. Like I was mentioning with the DB directory, for example, is I like to keep my database configuration and connection all in one place. In case I ever need to swap that out, I know exactly where to look. If I'm having issues with connectivity, I know where to look. I don't have to go looking for other places in my code. So it's helpful to my future self to really think about this ahead of time. Cool. Now we're going to get to some really, really fun stuff with the configuration. And this one is a little bit more involved. If I'm going a little fast, raise your hand. Hopefully you've been able to catch up with the slides for those of you in the back. With configuration, now can you build an app without dedicated configuration? Sure, you can do that. Now should you? I'd say nope. It's not a good idea. Having a good sense of configuration for your application, it'll give you flexibility, like in case you need to change some settings from day to day, if you need to use sensitive usernames, passwords, URIs, all that kind of stuff you want to make sure is easy to access, but also very flexible, that you can change it around. And you want it to be scalable, that a good system that can grow with your application, that you're not hunting for I just added a layer of complexity, how do I fit that in? You just want to plug in the values, whether you're in a dev environment or a production environment, you should know how to do that. And you want it to be maintainable, because ultimately it is a favor to your future self when you look back and you're not quite sure when there's just stuff everywhere. And it might be that sometimes you're working with someone who's maybe not as technical as you, and they just want to know how to maybe change a username or something. You don't want them to kind of be stuck trying to press the any key. It says press any key, and he's like, I don't know where the any key is. So let's talk about configuration. Now, what I like to use is Pydantic, and Pydantic, it leans very heavily on the type hint system. Oh, I think it's pulling up the, it was supposed to overlay over the Pydantic website, but not a whole lot for us to see outside of the idea that we're using type hints for the way that we define our configuration. We're gonna lean on that very heavily. Now, I don't want to spend a ton of time with type hints. How many of you do not know what a type hint is? All right, so there are a couple of us that aren't as familiar with type hints, and that's okay. Type hints are a way for Python to let you know ahead of time what kind of value is going to be assigned to a variable. So if we were looking at the PEP definition, this is just, sometimes reading a PEP it feels like reading an instruction manual, but it gives you the basic idea, which is when let's say you're defining a function and you're looking for, you're defining a function called greeting, and you know that it's going to take in a variable. You can tell this function what kind of variable it accepts. So over here, the greeting is of type string. So it knows that an assignment to the name, and by it, I'm talking mostly by our static type checkers like MyPy, your ID. These things might be worked into your own IDEs, VS Code or PyCharm, but it can help you prevent a lot of errors. That way, if you tried to assign the integer value to name, you would get some sort of error before you even run the code. You would know, oh, wait, I'm doing something wrong. And also, when you define a function and there's a little arrow pointing to the string class, it tells you what kind of value is being returned by that function. So pretty great. I think it's a great feature. Some people like it, some people don't. It does make the code seem a little more bloated at times, but it also makes it, to me, it makes it clear what you're trying to accomplish with any given function or assignment. So usually your type hints will look like this. You're defining a variable, right? So first up is a variable, followed by a colon, followed by a basic built-in class. So you can say a underscore string colon str. That's telling us that the value that's going to be assigned is going to be a string. Same thing with any of the other kinds of built-in classes like int or list or dictionary, bool. But what's really cool is you can also, let's say you can you create your own predefined class. This is my own class called PyCon tutorial. Now, when I assign a variable to that class and I create an instance of that class, I can do the same thing. So this tutorial of type PyCon tutorial is assigned to the class. So that's just a big primer on type hints. It's used extensively with Pedantic, Beanie, FastAPI, our 3 pillars. So again, I won't spend much more time with that, but it is, I think, an awesome feature. It really helps with the speed of development, how quickly you're building things, because your IDEs know how to do this in the background. They help with autocomplete and all sorts of other neat tricks. And Pydantic actually uses it for data validation, which I think is awesome. But for now, we're going to take a step back, and we're going to talk about the secrets that you want to keep from everyone else when you're building a web application, right? There are usernames, passwords, all that kind of stuff that you don't want getting out in the wild. Now, these secrets, they're the kinds of sensitive data that you want to keep out of your code. You want to keep it outside of your app. So if you noticed, we created an app structure. There's a project root, and then there's a app directory. But in our project root, that's where we have a .env file. And that .env file is going to help us. It's going to help us with environment variables. I'll talk a little bit more about environment variables. Just quick show of hands, how many of you do not know what an environment variable is? Okay, that's encouraging. There might be a couple of us which might not know quite as well, but it's something that you can spend a lot of time talking about. Our .env file will help us create and access environment variables as if they were built in your own OS or in your own system. But we want to make sure those secrets are kept out of our source control. That's why I created a git ignore file. No, but seriously, we want to keep them out of our source control. There's bots that are designed to look at repositories in GitHub and find sensitive data. And they know how to find those things. So just make sure that you're keeping those things out. Our environment variables are, I guess, I won't spend too much time talking about this, but they are these predetermined values that live in your system. They live in your operating system. So you can usually access them in your terminal in different ways. In PowerShell, if you use a $env : and then the name of the variable, it'll show you anything that's assigned to that. Or you can assign an environment variable which lives in your system, and then your application can use these variables that are not within your application, but your application can use them to then, to use in the app logic for connections, for example. However, if that application were to live on someone else's machine and they didn't have that variable designed on their machine, then it wouldn't work, right? But that helps keep those secrets out of your application. So that's why we're going to use this thing called python.env. It is included in that install from the requirements.txt that we talked about. This is just a library that reads the key value pairs that exist in that .env file, and you set them as environment variables in your .env file, and it'll help keep that sensitive data out. So your .env file might end up looking something like this, and like this. And you don't have to copy this. This is just an idea. We might have something that says our environment state is dev, and then, or you can change this to production, and then your app might take that value and do something with it. There might be a secret key that you're storing as a environment variable. You might have all your database information stored as environment variables. They don't live anywhere else. You want to keep them safe, right? And you might have your favorite song in there too. I don't know, maybe. So configuration for us will be contained in our core directory. So go ahead and build or create a new file called config.py. And you also want to put a init.py under your core directory as well. Now config.py will contain all our settings management, and we want to make sure that our configuration takes into account a couple things. There's going to be application settings that aren't necessarily secrets. FastAPI can take a number of settings that aren't necessarily all that sensitive. For example, you can give your application a name, you can tell what version it is, and these are all assignments that you can add to the FastAPI settings. But we also want to make sure that our environment variable, and these are the things that are more, I guess, more vital to the application, the actual secrets that are going to be used throughout, like our database connection keys or URIs, all those things are part of the environment. And then I want to make sure that our configuration system is able to make a distinction between a development configuration system and a production configuration system. Now you may, if you're just messing around, you may not think that you really care about that, but if you're building a useful web application, you are going to care about that. You want to make sure you can test things out locally, and then once you're ready to share your application with the world, you want to make sure that you're not sending fake data or your development database instance to the world. So those three things we're going to be concerned about. It's based, you can barely see it there. There's this article, and again, it'll be with the resources that I share at the end. There's this article by, I think the name is Redowan Delaware, where it's called Pedantic Configuration Management with Pydantic on his blog. Again, I'll share this later. Most of this section is based heavily on that, so I want to thank him for writing that. And it's designed to take those things into account. So we're going to start in our config.py file, so go ahead and open that up. And we're going to import a couple things at the top. From pathlib, we're going to import path. We saw that earlier. And then from Pydantic, we're going to import the base model and the base settings classes. And again, if you have the slides pulled up, as a matter of fact, if you want to look ahead and see what the more finished product will look like, you can go to that same website, pythonbynight.com, /examples, and it'll have the final file within there as well. You just need to use the arrow key to find the file that we're talking about. But if you're building along, the next thing I want to do is create an app root variable. I like to do this because there are many times within your application that you might want to know where you are relative to the root folder. And this is the, for me, for example, this would be the project_root, or I guess GHW/app. So that's our project root. So the path, if you're not familiar with path, the path dunder file there is the location of the current, where we currently are. So this is config.py, where we are there. When we do the .parent, it just moves up the directory until we're in the app directory. So now our app root is a path-like pointing to our app directory. Okay. Next, we're going to build a couple classes or class shells, I would say. You may not need to worry about copying all the comments there. That I find them helpful, the doc string. So at least if you're trying to do it to save time and not putting too much in the doc strings, that's fine. But I do love my doc strings. They really help a lot as you're scanning your code. So, and the ellipses there, in case you're not familiar with ellipses, is the equivalent of pass. So it's just a shell of a class. We're going to build an app settings, and app settings is going to inherit from Pydantic's base model. Now notice Pydantic has two different classes we're pulling from, base model and base settings. Pydantic is taking care of a lot of the validation. Then we're going to have a global settings class that inherits from base settings. So anything that we define in our, so this is inheriting, from Pydantic base settings class. And now base settings from Pydantic is a great configuration management tool. This is what we're leaning heavily on, this base settings class. So you can imagine in the app settings class that we defined, that might have some of the application settings that are not necessarily secret. We might define things directly there. Under global settings, these might be some of those secrets we want to keep from the rest of the world. But we also want to make sure that we have dev settings that inherits from global settings and a production settings that inherits from global settings. We'll be able to use these two classes to then separate out one thing from another when it comes to development configuration settings that are specific. Let's say you have a development database that you're working with. This will ensure that one loads. How it does that, we'll find out soon. And lastly, there's a factory settings class that is not inheriting anything, but this will actually be a callable class. This will look at one value, just one value in our environment variables, in our environment variables. It'll look for in either dev or production setting, and the application will take care of the rest, and we'll see how that works in a little bit. Now, in order to make sure everything's working okay, what I want us to do is go ahead and open up that .env file. The most important line here, line 3, says env_state equals dev. That's for development. And the hashtag is a comment. You can say or PRD for production. These are the values I'm going to use to determine whether I want to load my development settings or my production settings. And then go ahead and you see two different values there in 5 and 6. My development favorite song and my production favorite song. There's a song I like to listen to when I'm on development mode called Fortress, and there's another song I like to listen to when I'm in production mode, and that's Laurel. So go ahead and type in whatever songs you want there, whatever your favorite song might be for either one of those situations. So again, we have the end state, that's the most important piece, and then the songs. All right, let's go back to our config.py. In our config.py up at the top, we're going to import the optional, it's from typing, import optional. So optional is one of those things related to type hints. With Python, when we were saying some value : str, you can say optional str to let you know that the value associated could be either none or a string value. So that way, it makes sure that you can have a none value, which is not str, but you can have a none value or a str. So that's what optional is going to be used. And we want to add the field class to the Pydantic import, so add that there along with base model and base settings. And once you have that, we're going to go back down to our global settings class, and we're going to add a couple values there. So now we've defined our app root, our root directory at the top. But now I want to make sure that that root directory is available everywhere else that I might need it with my settings class. So I'm going to go into global settings, and I'm going to create a variable called app_dir, and it's of type path. Yes, sir.
What was the link for that in the slides again? I'm sorry.
Yes, the link was pycon.pythonbynight.com. And let me know if you're, and again, like if you go to that, it's right there on the screen, pycon.pythonbynight.com. Okay. And if you go here to the trailing slash examples, I believe, you should be able to see the finished version of this file, so that in case you just kind of want to see it as you're coding along, that's also helpful as well. Any other questions so far? All right, so we're going to build that app root, and then I'd say the most important line, if there's anything that you're noticing, this is the most important line here in this class. So we're creating a variable called env_state, and this is where you see that optional value that we, or optional class that we imported from the typing library. And we're saying optional bracket stir. So this is saying that this m_state value can be none, or it can be something else, but it needs to be of stir. The field class, the Pydantic field class, is doing two things here. First, it's providing a default value of none. That's that first piece that you see there, none. And then the env assigned to m_state, what that is actually doing is saying, look for an environment variable called m_state. So if we have an environment variable in our system, whatever it may be, let's say we called it development or staging, this will now be assigned to our configuration class, right? But we also need to tell Pydantic also needs to know that we have a .env file that is handling our environment variable creation. So to do that, we go at the very bottom, and we're actually going to create a subclass called config, and this is all in the settings management for the Pydantic class. So if you go to the Pydantic website, to their docs, they talk about what's going on here. What you're saying here is you're supplying Pydantic where your .env file is located. So you'll see that I'm actually using our app root, which again is not even the one because we haven't defined yet the app_dir. So I refer to the app root, which we defined at the very top of our file. And we're going .parent. So now we are in our project root folder. And now we know that there's a file there called .env. So this is telling Pydantic where to look for those environment variable definitions, the ones that we just created. So if you created something like mine, it's going to know that there's an env_state variable and a couple of our favorite songs in there. Let's ignore the db_URI. You don't have to write that one in, but go ahead and write in favorite song variable, and again, optional string and equals none. Now you may be wondering, this is interesting, why did we put both our favorite songs in the .env file? It feels weird that we're using a prefix for our development or our production variable in that sense. But the reason we're doing that is because now we can use Pydantic, another feature of Pydantic, which is the env_prefix assignment in our dev settings on our prod settings classes. So you'll notice here we're also subclassing config in either one of these, and the M prefix, this lets Pydantic know that when you are calling your dev settings, the environment variable, the appropriate environment variable that it's looking for will need to have the prefix of dev underscore. So you'll notice in our global settings, we just have favorite underscore song. We didn't write the dev underscore or the PRD underscore. We just wrote favorite song. This will ensure that the dev underscore prefix is added when we call the dev settings class. And now Pydantic will know to read the song that's relevant to our development environment. Last, this one's a little more involved, is our factory settings class. So now we want to go ahead and create a callable class that will load our appropriate environment. So we're going to do a def init here, and this can get a little referential, so you're pointing at a lot of different things. When we call this class, we're going to provide either a dev or a PRD string, right? That's what it's going to look for. So we're saying factory settings def init mstate :optional stir, and then it's going to assign the mstate internally, right? And then actually this is where we're making the class callable. That's right. So then we're going to create a dunder method for call. And some of you who are perhaps a little not as familiar with these dunder methods, it does take some time. You're kind of giving this class a behavior that otherwise wouldn't be there. There may be some different tutorials that you may want to look at to get more familiar with some of these dunder methods. But here what we're saying is, if that M state that we're using to initialize this class is dev, then we're going to return the dev settings. But if it's PRD, if the M state is PRD, we're going to return the production settings. Very straightforward. And then I like to have an else, which gives a value error. It just says, hey, what you provided wasn't dev or PRD. It was just gobbledygook, and so you provided an invalid M state. I'm using an F string there. If you're not familiar with F strings, they allow us to provide a reference to the variable there under curly brackets. Raise a value error. All right, so with what you've seen so far, one thing that I find really great is that the logic is pretty straightforward. If I'm in dev environment, load dev settings. If I'm in production, load production settings. You don't have to go in there. What ordinarily could happen is, all right, I need to load dev environment. Let me go in there and change all these values, my username, my password, all these things, and then run, and then hope I didn't mess up typing something. Now you have all your production and or dev settings in your .env or in your environment as an environment variable, and all you have to do is worry about one value, which is, am I in dev mode or am I in production mode? And lastly, what we do is we're going to assign all of that to a variable that then we can use throughout our application. That variable is going to be called settings, and we're going to assign it the factory settings. This looks convoluted, but it's fairly straightforward. Our factory settings class, and then you'll notice that inside of it we have global settings with the parentheses dot env underscore state dot m state. That's what is sending the string value of dev or PRD that comes from our .env file. So now we have a pretty robust system. And if you want to try this out, I don't think I have. Yeah, let's go ahead and try it out. I don't have that part built here. What you're going to want to do, let me bring this up again here, because I didn't plan for this, but I think it'd be neat if you can see. What you're going to want to do is make sure that you are in your project root directory and that your virtual environment is activated, and type in uvicorn app.main app reload. Type that in your terminal. If you have VS Code, you can usually open up a terminal, or you can see if you can run. And it shouldn't do anything. You just want to make sure that it doesn't have any errors. And then if it seems like it's working, at the bottom or right below where you're assigning that value to settings, go ahead and do print settings. And it should give you something that looks like a dictionary. You can put that at the very, very bottom of your config.py. Does anyone see their favorite song listed when you run that file? Actually, this won't work right now, now that I'm thinking about it. I'm sorry, I got ahead of myself. This will only work after we have our FastAPI running and looking for our settings. But you should be able to just print settings at the bottom of here. Just add print settings and run the file, see if that works. And you should see something that looks like a dictionary. Does that work for everyone? Cool. So if you were to go into your .env file and change if you're in dev, change to production and hit print again, you'll actually see that it's looking at your other song now. So it kind of knows how to switch specifically off of just that one top line for M state. All right, so what we're going to do now is we're going to go ahead and go back to our .env file. Now, I realize this is kind of hard to see. I'm going to see if I can make this bigger. These are the MongoDB credentials that we're going to use to connect. I want to see if you can, let me move this out of the way. If you can create a .env file that has the pertinent values based off of kind of what you've seen so far. And I might be able to make that a little bigger, maybe. I don't know if this is any better. Can you see that a little better? Hello, is that everything? So what I'm going to do is, I'm going to show you what it looks like for me. So yours should likely look a little bit similar to this. It's missing at the top you have the end state should still be there. You don't want to get rid of that one. That's what's going to drive the behavior. You'll notice what I've done here is for the scheme, you could have called it DB scheme or database scheme, something to that effect, whatever you called it, it's fine. I like to call mine Mongo scheme because let's say I were testing between two different kinds of database solutions. I like to know, I kind of like to know more or less what I'm dealing with. So let's say I have some document DB stuff here, then I'd likely be assigning to something more indicative of what I'm working with. So I've used dev Mongo scheme, dev Mongo host, but you'll also notice that for the scheme and the host, I'm kind of violating the dry principle, right? I'm repeating myself. That's the same value that's being assigned to two different variables. The reason I've done that is because a lot of times, in this case, I'm working with two databases in the same Atlas account. So my development database is using the same scheme and host. However, there may be times that you don't want to be doing that. So let's say you're prototyping, you start working with both a production and a development instance using Atlas, but then you realize, you know what, I kind of want to have a local version of my development. I downloaded the community edition, and I just want to do that. If you have your own credentials, actually, this would be a good time to use them. If you have used MongoDB Atlas, there's this thing called connect to app, and it kind of shows you the URI string, but you can get a sense of what is what by looking at this. But again, it just gives you more flexibility to name them both, the scheme and the host in either instance. And one thing that I think is hopefully self-evident is that you can always just add an additional tier. Let's say you wanted a staging tier. You may just replicate all of this and use STG, for example. And then in your config.py file, you would just need to create a stage config that inherits from global config and use that same kind of pattern that we're using. So you could have multiple environments, not just the two. But again, we're going to be working with a development and a production environment. All right. So again, we're going to go back to what we're working with here. And now, if you wanted to make sure everything's working, you actually don't need to use all those print settings. You could just, this is main.py. We're going to import our settings, which we've defined in config.py, and you can just print settings. You don't have to do .env. You can do all those as well. But if you've been following along, it should look something similar to this. Or if you just do print settings from main.py, it'll give you that same kind of dictionary view. That's a pydantic view. You can also view a pydantic model as a dictionary, so you could also do settings.dict with parentheses. But I think print settings works just fine. All right, anybody got this working with their main.py? All right, let's give a minute or two more. Actually, I think you may need from app.core.config, depending on how you've set up your IDE. Sometimes your IDE might complained that it's not seeing the root directory. So if it's not working for you, try from app.core.config, import settings. Okay. All right. That concludes our configuration piece. And again, my little recap here is that Pydantic is the big hero here. We're leaning heavily on Pydantic, and we're inheriting from the base settings class. The base settings class allows us to access our environment variables as well as to use our .env file that we use. It's a very flexible system that can be used in many different ways. I talked about how you could add tiers, like a staging tier if you wanted to, fairly easily, and it's scalable and maintainable in the sense that, yes, if your app is growing, you have it all in one place, you know where you can make changes, and we're gonna go ahead and use that configuration in our next section where we're actually starting to deal with the database connection. However, we have reached our break time, so we're gonna take about 10 minutes to stretch our legs, maybe go grab some water, and I'm gonna put let's see, I think I can put let's take 10-minute break, so let's be back. My clock says 2:52, so let's do 3:02, and then we'll just get started right then. So I got a couple questions during the break. Again, some of the code that we'll be using is available at that same website, trailing/examples, and then you just use your arrow key, and it tells you at the top which file we're working on. So that's kind of the finished product is going to look like. And also, and also, I will, after this is all done, I will have example code up on GitHub as well. I do have the GitHub repository that I started building that I mentioned about at the top that actually covers a lot of the same material. And if you miss something and think you might need a little refresher with, hey, we were talking about configuration, I wanted to get a little bit more background, I'll send that link after this is done. And also, I'll be available at any time if you find me after the talk or on the conference floor. Happy to talk to any of you. All right, so let's get moving. We're gonna start talking about database. My preferred database at the moment is MongoDB. So MongoDB in Python. It's a great solution, I believe. Some people prefer, a lot more people are familiar with SQL. In the survey that some of you filled out, and thank you, all of you that filled out the survey, it seems like at least half of you have heard or dabbled with MongoDB, but we don't have, I don't believe any of you responded with any of you are actually using it in any production environment or anything like that. So that's okay. This will get you good exposure. Some of these concepts that we're gonna learn here about how to connect to a database and how to build a model, that can be transferred into other SQL type structures. I think FastAPI, for example, the creator also created this great library SQL model that follows some of these same patterns. So and it's built on top of Pydantic. So again, a lot of that will be there. Now, there are some reasons I like the MongoDB style. It stores data in a JSON-like structure. So, and if you're familiar with Python dictionaries, you're familiar with JSON. And it has async support right out of the gate. It does allow for ACID transactions. I know early on in the life of MongoDB that was a concern. Also, the migrations are a lot easier than in something like SQL, because you're not so concerned about having to rebuild tables of some sort. But those are some of my reasons. Your mileage may vary. Now, when I'm talking about a database model, the way I'm using it, I'm talking about the logical structure of your database. Is more of a mental model. And these relationships have certain constraints, like if you're thinking about a table, for example, that might contain some sort of data, you might think, well, everything in this column should be an integer, and everything in this column should be a date, and everything in this column should be a string of some sort. Those are constraints when we're talking about a database model, and what kind of access you have. Those are the things we talk about with database models. And this applies not only to tables, but also to the MongoDB document-based models as well. I want to stress that it's important to spend a lot of time thinking about your database models in this sense, whether you're using Mongo or not. Now, so one of the things that people think of when using the MongoDB or document style databases is like, well, you don't have to have structure. You can put in whatever you want. And while that is true, you'll end up in a world of hurt if you're not keeping track of what you're putting in your database. It'll just, again, I just get that visual of tons of icons on a desktop, and I just don't know where to go from there. You can do it, but accessing the data will be more difficult. So spend a lot of time away from your keyboard. We don't have that kind of time today, but when I started building my website, for example, I just put away my computer and I just pulled out a piece of paper and just started thinking about what are the kinds of things I might use on my website that I might want to keep track of. These things also matter because you have to pay attention to little details. Some things you may not have thought of if you just started coding. So a lot of people have that tendency is, hey, I'm going to build something, I want to start coding. So you open up your computer, your fingers are on your keyboard, and you just kind of start going, right? My encouragement here is just to actually spend some time thinking about it. That's just a broad overview when thinking about database models. But in the meantime, we're going to take a small little detour and we're going to back up again. We talked about configuring our database somewhere else than, now we got our connections and our passwords maybe in our settings, but we also have to think about the database and how it's going to communicate to our Python program. So we're going to do a little bit of configuration again. I do like to keep that configuration separate. So it helps, again, if you're ever hoping to migrate from one system to another. We're going to go ahead and go into our DB directory, and we're going to build a file called db_config.py, and go ahead and put an init.py there as well. Now we're going to use our .env file. Again, it should look something like this. I hope that we all have something similar. I like to keep these songs down here because it kind of helps with debugging. Just I get a sense of what I'm looking for. So in our db_config file, we're going to import optional again from typing. And I lost my mouse. Hang on one second. From typing, import optional. We're going to import our settings. Oh, and you know what? Now that I think about it, there might have been a piece of config.py that we left behind that we needed to do. So I'm actually going to, even before that, if you have that, it's fine, but let's open up our config.py, not our dbconfig.py. Let's open up config, and we're going to look for our global settings class. And notice that we've done the same thing we had done with favorite song here. I'm creating these variables, Mongo scheme, Mongo host, Mongo port. We may not have created a Mongo port in our .env file. You will need a port variable if you're running a local instance of MongoDB. Mongo user, Mongo password, MongoDB. And again, because similar to the way that our settings knew which song to pick, these variables will be populated based on what's in your .env file. So I think I had kind of glossed over that earlier. And again, if you are on the website of python.pythonbynight.com/examples, this is on there as well. All right. Okay, so we're back in db_config. And from Pydantic, notice that we're picking a class called anyURL and another method called validator. It's actually a decorator we will be using. This ensures, what we want to do is we want to take those pieces that we've defined in our .env, and we want to make sure that we build the correct URI string and that we connect to our database with no issues. So Pydantic allows us to validate that the URI string that we build is valid. That's what the anyURL class there is doing. And the first thing I'll do is I'll create a MongoDB URI variable. We ordinarily will not be using this variable, we're not going to be assigning a value to this variable ordinarily. You can use it if you want to plug in a quick test. You just loaded up an instance of Atlas and you want to try to insert the URI in here, you can use this and our application will understand it. But really what we want to do is we want to build the URI based on those settings that we define in our .env file. So this validator here, if you are not familiar with the decorators, what this decorator that is from Pydantic, what it is doing, it's creating, well, first of all, it's going to validate to make sure that this variable is a valid URL. If not, then we're going to go ahead and build a valid URL. So the validator, what's going on here, it's looking at this variable, MongoDB URI, and if you want to learn more about some of these parameters, you can look at the documentation in Pydantic. But we're creating a function that's saying this URI is valid. The CLS is referring to the same class. The V is referring to this value of MongoDB URI. If it is if is instance, this is a Python method. So it's checking that this value is an instance of any URL, and if so, it's going to return that value. So that's the first part that it's doing. That's all this decorator is doing. So that's pretty cool. But what we want to do is we want to build our URI. So to do that, let's pretend that those ellipses there are the part that we just built. So I just wasn't repeating it here, just so you could see what comes next. Next, if settings.mongo host in localhost or 127.0.1. So this is letting our application know that the Mongo host we have defined in our environment variable is a local host. So if any of you were able to get a Mongo instance running locally, this would allow you to connect to that instance, because in your .env file for host, you might have written in localhost, or you might have typed in 127.0.1. The reason I am looking for localhost is because the way you build a URI for a localhost is a little different. We need a port number, for example, where you don't need that. And the scheme is different when you're connecting to Atlas. So if settings.mongo host in localhost, try, and then we're going to go ahead and add some code there in a little bit. We're going to build the URI string for the local MongoDB. For right now, I'm just passing. And the except clause here is we're going to raise an attribute error, basically saying one of the attributes that we were working with was wrong. So then this will validate, right? So that's only if the Mongo host is localhost. In that same indentation, with all other patterns, we're just going to go ahead and try to build our URI with the current settings. And that's the one, that's kind of like the default. If it's not localhost, it's going to default to this. We're going to try, and we're going to add some logic there, and then use the same exception. All right, so let's go back and take a look at what that looks like. We have the validator there making sure that the Mongo_DB URI is valid if it's an instance. In this case, it's not. So now let's check to see what happens if it's a local host. What this is doing, the AnyURL Pydantic class also allows us to build a valid URL string, which I think is amazing. It's pretty great. You pass the scheme, host, port, user, password, and you can even pass in path and query parameters that are identical to what you will get from your MongoDB. When you're trying to connect to MongoDB, these path and query settings, I think may not be required, but the documentation tells you that it's helpful to add them. So we're going to try to return the AnyURL build using the settings that we defined in global config. And again, remember, this is what's really cool, is we're just using Mongo_scheme, Mongo_host, but based on whether we use the development version of our environment variables or the production version, it'll insert the appropriate credentials. I just think it's really cool. We don't have to worry about separating this out here because we've already done that in our settings file. So this build here is specific for localhost. You'll notice that we have to include the port number here. However, for most of us, if you've been following along, the next piece, and that's the exception we already talked about, the next piece is similar, but all it's doing is it's getting rid of the port number. The scheme becomes Mongo plus SRV, and the port number is not necessary for the connection to Atlas. And that's pretty much it for the DB config for now. All right. So one thing, I'm not going to get too far into this. When we are establishing a connection with MongoDB, we need to initialize a client. This is going to be handled by a library called Motor. you'll notice it wasn't in the requirements. It's included with Beanie, as Beanie is in the one that we did install. You don't have to worry about this for now. This is what initializing a client looks like with Motor. We initialize a client and then we use that within our code. That MongoDB, let's say that were the URI string, that's where we're going to insert the URI string that we just built, and we'll look at that in the next section. So this client business will make a little bit more sense. But you know, this is one of those things where you can just really get derailed. When I was getting to this point, when I was getting started, I was like, Motor? What is this Motor business? I had no idea. It's a coroutine-based API for access to MongoDB using Tornado or Async IO. Again, it's a lot of under-the-hood stuff, but for our purposes, we're not going to spend. You have read the docs if you want a little bit more information, but again, it's pretty heavy. Not something you necessarily have to understand with what we're building. You just need to put the pieces together and start moving from there. So that's more or less what we're doing with our database connection. We'll come back to it as we move forward, but I like to make sure that I have a separate configuration system, a way to build these URIs. And if you start thinking ahead, you can almost see how you could use it to build a URI string for a Mongo instance versus a SQL instance, for example. You would just need to look at the scheme and say, if the scheme includes, you know, Postgres or something from a different kind of URI that you need to build, Pydantic can do that for you. So you can really extend that out. You can build those URIs from all the parts, and then you can validate that with Pydantic, which I just think is fantastic. It does that all under the hood. It uses those type hints that we talked about, and you will do yourself a favor if you spend some time looking into Pydantic itself. It's just such a great class for a lot of different reasons. We're going to use it a lot also with Beanie, which we'll be looking at next, and with FastAPI, which is what we'll finish with. So that is our next section, is going to be on the database models, not these kinds of models, just the database models. You may have heard of a object document mapper, or maybe an object relational mapper, an ORM or an ODM. These are the ways that our Python application will be talking to the database. Now, an object document mapper, when it deals with documents like the ones that are used in MongoDB, they're a type of abstraction, right? It's basically a Python object that maps to the database. So you're thinking of things. I like to use the term mental model a lot, just things that make sense in your head. The database is this thing out there somewhere, and you're trying to make sense of it through objects in Python. And that's kind of what these ODMs are doing, both on a mental model basis, but also in a Pythonic basis, right? This is Beanie. This is the library I like to use as my ODM of choice. I believe there's one or two others that work really well with FastAPI. I enjoy Beanie for its simplicity, and it's very approachable. And the maintainer, Roman, he's very friendly, active on Twitter. If you ever reach out with a question, I'm sure he'll be happy to answer. Beanie also uses type hints, as you may have guessed. It's built on top of Pydantic, so a lot of what we do in Beanie, it's similar to what we've already been doing. Now, for some of you that may not be as familiar with MongoDB, there's a little bit of terminology that may be helpful. When you're dealing with SQL, most of us are familiar with what a table is. It's something you might see in Excel, for example. A table contains rows and columns that you can categorize. All the columns represent the different kinds of data you might have in that particular table, and the rows are each separate instances of that data, right? So in MongoDB, a collection is approximately the same thing as a table. So you might think of let's say I'm creating a table for my articles on my website. I have a collection called articles. With SQL, it might be a table called articles. Now, in SQL, a row of data might be one instance of an article which contains the title, the date it was published, all the sorts of metadata that I might have for that particular piece. In MongoDB, that's referred to as a document. When I was familiarizing myself with MongoDB, I kept getting collection and document confused, and it's natural when you're kind of trying to get used to a new nomenclature, but I hope that this very simple kind of correlation can kind of help you understand which is which. Now Beanie, again, is pretty awesome. This is just straight from their documentation. Getting set up in your code is really easy. You just write your database model as a Pydantic class, and then instead of using Pydantic base model, you use something called document. That's just the class name is document. And then you initialize motor, which we talked about previously. You initialize a motor client, and then you call a Beanie method called initBeanie with the motor client and a list of the Beanie models you're using. I know it sounds like a mouthful, but it's actually very straightforward. We're going to look at how that works. Again, an example of a Beanie collection actually I wanted to go through this. A collection, again, let's say a table in Beanie might look something like this. This is just an example. My database model inherits document from Beanie. I give it a couple of attributes there, name, description, category. You'll see that there's some type hints there that kind of let you know what's going on. And then a subclass called collection, and that allows you to call your table whatever you want it to be. So in this instance, this table or collection would be called pinback. Now, a couple things to note here is that the type hints here for the first one there, name :str, Beanie will treat this as a required field for your database. So if there's no value associated with name, it'll give you an error. You'll see that the description, it is also a required field. However, it is already assigning it a value, so it will default to awesome. So you don't have to define it when you're assigning, when you're assigning values. In this instance, you would only need to assign a value to name, and this would post to the database with whatever the value is for name and awesome as a description. The category there, you'll see it's optional. So it can have a null value, or it can have a string value. But Beanie would not tell you, hey, there's an error going on here. And again, Beanie, Pydantic. Now, what a document looks like, say in MongoDB, it might look something like this. It's kind of like a dictionary. The underscore ID is similar to a primary key in SQL. It's just the unique identifier for this particular document within a table. You'll see it has a name, a description, a category. This is what a document would look like. Now, what would a document look like in Beanie? It might be a little confusing. You'll notice that when we do this, we're using the subclass document, but this is actually more representative of what a collection looks like, because this is defining our table value, our collection. When we create an instance of this myModel class, then that tells us we are going to be inserting a row or a new document to the database. So a document in Beanie might look like this. A new document, we're assigning it myModel with the assignments to each of these attributes. Very straightforward stuff we've seen. And then to save this to the database, it's really long and complicated. No, just kidding. We would just need to do await new document.save. The await there is for the async stuff that FastAPI, Beanie, Mongo all does. I won't spend a ton of time with it. What I've found is that I actually didn't even really need to understand async and await to get to use it. I started using it and it works great. But again, the method to save this to the database is very simple using Beanie. New document.save. You can also use, there's aliases to some of these, so you could use new document.insert if that works better for you. So now, why don't we go ahead and connect ourselves? We're going to try to connect to the database and see if we've, if we're doing everything right here. So to do that, we have to do two things. We have to go ahead and build a model, which will be representative of that, of the collection, right? And then we need to see if we can, the reason we need to go ahead and build a model is because we need to pass the model to the initBeanie method to know what collections it's going to be, or what models it's going to be using those methods like .save, insert. You'll find methods for all the usual database operations, so find or save, delete, etc. So let's go ahead and create a new file under our models directory. This one's, I just called it FAVS, favs.py. This is our favorites, favs.py.
It actually says it's a markdown document.
It should probably be a py document. That might be wrong in the examples. Is that what it says in the examples? Or where do you see that?
On the, yeah, an example just says
Yeah, it should be .py. All
I figured so.
right, so models or models/favs.py and then an init.py there. But before we get into that favs, let's open up our db config. We're going to do one more thing. We're going to add a couple imports there in our db config. We're going to import initBeanie from the Beanie library. And we're also going to import the async IO motor client, which will allow us to instantiate our client. And we actually have another import up there. That module we just created, the favs module under models, we're going to create a favorite song DB class when we're there. It's not built yet, but go ahead and add it here. Say again?
Actually, we import the classes to the init method. To the render init.
No.
Because we create two files, right? One is the favs and the other one is the
Right, so the init file, what it's there for is to allow for you to import from that directory as you would from other directories, but it's not doing anything in this case with our code. There are times where you might put some code in those init files and do stuff in there, but for this tutorial we won't be putting any code in our init or using it in any of our imports. It allows us to then import the favs.py. That is a good question. All right, now in that same database connector class, I'm skipping a little bit of the code that is up here with ellipses. We've already created our validator. Oh wait, no, this is, yeah. We've created a validator up there, it's hidden. There's this new method that we're creating, this class method under database connector. It's called initializeDB. And we're going to go ahead and start a DB client with Beanie and load our documents models in there. So notice we're going to put client equals async IO motor client, and then we're going to refer to this MongoDB URI that our class is constructing. So this will instantiate a client, a motor client, that our init Beanie method is going to use. And we're going to tell this function what models we want to include. For right now, we're only going to include this one model that we haven't yet created. We're going to create that next. Now, one thing that I noticed pretty quickly doing this was each time I create a new model, I would need to come in here and add a model to this list of models, and I would need to feed it to the init Beanie function, and that's very correct. I actually created a dynamic model loading function that just looks through my directories and finds all the models that are Beanie models and loads them into this list. But for now, we're not going to cover that piece. I do cover that in one of my blog posts on my blog if you want to read about that. But that's one way that you could ensure that you don't have to come back here. So then we're going to go ahead and try to connect to our database. And to do that, we're going to use the init Beanie function. We need to pass it a database. The database is going to be client, and client being that async IO motor client that we just instantiated, and we're going to pass it the database from that client. And we've already defined that database in our .env file. And if that doesn't work, we're going to throw an exception and say that we had a connection error, something went wrong. Notice that these this is something I learned pretty late. Again, we want to create a useful app. This is something I learned pretty late, which are these exceptions can be really useful when you're debugging and where you're working with your application. You can know exactly where something went wrong. So I'm adding a connection error here. I could even put the name of the database using an F string here so I'd know where I failed. And they can be very useful. I hadn't been doing this early on, and it would be harder to debug. So that's why I'm throwing different exceptions in different areas. And at the very end, notice that now I've hidden the database connector class and the initialized DB method. At the very bottom, I'm just creating a variable called DB, and I'm assigning an instance of this class database connector. So that's the clincher. That's what we're going to use actually in our main.py when we're importing our database settings. We're just going to use this variable here. All right, now let's go back to our favs.py, my favorites. And we had already done the top 3 things there. From Beanie, we're importing document, and from Pydantic, I'm pulling base model and field. I'm going to show you a pattern that is typically used when defining database models. I've seen this both with Mongo or SQL, so it might be something you see. It might not make a lot of sense when we're doing a small bit of data like I'm doing right now, but it becomes useful later on. What you ordinarily do is you create a class that, in this case, I'm inheriting from base model. And then I'm creating another class, which inherits from that first one. And then that one is called favorite song create. And then a third class that's called favorite song DB that inherits both from favorite song and from the Beanie document. So really, the only class that our database is worried about is the very bottom one. And the top one it's basically a Pydantic class that we can use to define what kind of data exists there. So this is where I would spend a lot of time, would be in that first class kind of thinking, what are all the kinds of things I might need in this class? What are the kinds of data I might want to store? Even if you don't think you need it, you might just want to include it, or if you think you might need it later. These are kinds of, again, if we had the time, kind of the things you would spend a lot of time with. That's how you would define the class. Then the next class down, favorite song create, that's what we use within our methods when we're creating a class. We use that class to then populate the different pieces that are missing, whether song, title, artist. And then once we have the values here, we use those values from within this class and we unpack them into the favorite song DB to then save into the database. This separation of concerns makes it harder for someone to get access to your database because they're only ever interacting with that kind of like the middleman class. There might be another one called favorite song update or something like that, but that's just a kind of a pattern I've seen that's pretty useful. So if you're coding along, go ahead and add these values to the favorite song that's inheriting from base model. The middle one, favorite song create, we're just going to go ahead and pass. And since this third one is inheriting our Beanie document, we're going to give our collection a name. It can be whatever you choose. I've just chosen favorite _ songs. And this collection is going to have some values, a song title, the artist, and a description. It's a very basic. I'm not spending a lot of time with this because this is not, the ability to create a web app is not the same thing as the ability to work, to have a robust database model. There are different ways of thinking about that. If you want to get an idea of kind of what that looks like, here's a kind of a truncated example of what my base model might look like for my articles on my website. And there's more than this. I just kind of trimmed it down. You can use Pydantic to do a lot of really cool things. You'll notice that the Pydantic field class can constrain the length of certain fields so that it'll throw an error if I try to create a title that's over 85 characters long. These constraints are actually really useful for a lot of reasons. Let's say I forgot that I was inserting a main title and I put in my entire body of my text into the main title field and I hit update, and then now I have this weird field with all this crazy data in it. By creating it this way, Pydantic or Beanie would throw an error saying, hey, this title has too many characters. And so I would know that when I'm dealing with an article, the title should be 85 characters or less. My meta description shouldn't be more than 155 because that's helpful for SEO reasons. And I can have Booleans saying that this article is featured or not featured. And you'll see that over here, the featured flag is set to false. So anytime I create or update, anytime I create an article, it just creates, it's not featured unless I explicitly tell it to be a featured article. So these are some of the more advanced features of what you may see in a Beanie class. And again, I talked about constraining the length. I talked about having either the bool flag set to false or having optional values. And you can even say that something for like a featured image, you're looking for a file path. And if you're not providing a file path, it's fine. But if there's some data in there and it's not a file path, then it'll throw an error. So you'll see that I have an article create. I have an article update. This article update allows me to know what fields I want to be able to update, because I might not want to update all the fields. So this gives me the ability to set that. And then this is my article DB, which has, in addition to all those fields, anytime I write something to the database, actually that created at their datetime now shouldn't really be there, because I think even if I update something, it would use the current date. But that's just an example. But you can create different ways of dealing with the base model, stuff that is only backend only, that you might want to keep it here. Again, to kind of look back at the mental model of what's happening with all of this, an object document model is really just a way of managing the way your application is talking to the database. So you have your ODM, in this case Beanie, and you have all these little Beanie documents over here. They're just instances of that ODM that then talks to the MongoDB database. So then if you're looking at, oh, you can't really see the code, but those are some of the code we've seen already. The Beanie class that, you know, when you inherit from the Beanie document class, that's representative of that ODM. And then all your instances of that class are all the little documents that you use in your Python code, and they all talk to your MongoDB database. Well, I think I could have made it a little bigger. That then MongoDB database, all they need is a JSON-like object that has the underscore ID, that's an object ID. And Beanie handles that object ID. You'll notice that I never defined an underscore ID or an ID value in any of my models. That's because Beanie is handling that under the hood, and you don't have to worry about it. As soon as it saves to the database, it has its own object ID, and you can refer to it. You can call that ID later if you're trying to find a document, but it's all under the hood. Okay, that is our models. To recap, yikes, too fast. We talked about what an ODM is. If you've heard of the term ORM, Object Relational Mapper, it's the same thing in terms of what you're doing with a SQL database. One of the most popular ones is SQL Alchemy, but there are many others for those kinds of databases. ODM refers to a document type database, hence the name. We saw how to actually connect to a database, right? We now know more or less what we need to do. And you know what? I feel like we missed something in that. We never actually connected to a database. Let me think about this. I think we'll do that next in FastAPI, yeah. So we're 2 hours, 20 minutes in, and everyone's here wondering, I signed up for a FastAPI tutorial, and we haven't even touched it yet. You're probably thinking, oh, this guy, finally, good grief. And here's what I want to stress, and this is something that I took for granted. When I thought I wanted to build a web framework, I downloaded FastAPI and started coding, or Flask at the time. But if you do that, you are going to get stuck. Like all this stuff we've done already, I just had to go back and do it and try to fit it into what I was already doing in my application. That's why it was a bit of a misdirect, and I apologize. But I do want to emphasize the importance of those topics we covered, just having a great skeleton for your application, because that's going to make your life easier. If you have great ideas about some API design or some web features that you want to implement, all of that is going to have to be done, and done even better than what we could do in a couple hours here. So we're now going to see how we take those pieces and apply them into FastAPI. FastAPI is great. That's why we're spending less time with it, is because it is easy to get up and running. The documentation is great, and all it really needs is your ideas and a good foundation, and you're up and running. So we're finally here. I'm super happy about that. And guess what? We're just going to have to build a hello world script, I think. So we're going to do it this way, and we're going to build from this. I like to create a function called getApp. Most hello world scripts might skip that function definition, and they'll just create an instance of the application and have you run it, which is pretty easy to do. And what you'll notice here is we're from FastAPI, we're importing FastAPI. And like I said, I'm creating a function called getApp, and you'll see the little arrow there. That's just telling us that we're going to return an instance of this FastAPI class, right? And then this is what you typically see, app equals FastAPI parentheses. That's what you typically see in a Hello World. And ordinarily in a Hello World tutorial, you might see a decorator that says app.get, and the trailing slash there just tells you that when you go to this endpoint of backslash, we're going to return something. Now the async def there is you can use def or async def. It can be called whatever you want, actually. This is just a function that you define. All it's going to do is it's going to return a message. Ugh, hello world. And then lastly, one important point is you want to go ahead and set a variable to that function definition. So assign the getApp function to app. And once you've done that, you can go in your terminal. If you're in VS Code, you can just open that up, or if you're still in your original terminal, just make sure that it's activated with the virtual environment and that you are in your project root project root app folder, and just run it. So it should look something like this. You don't have to use the Python M. I feel like for me, it always kind of helps me ensure that I'm using the right Python, but you can just type in uvicorn space app.main : app, and then -- reload. That's the option. If it looks a little cryptic, all it's doing, it's calling from the current directory, which is app, and then the dot notation is the next, the module, so app.main, main.py is our module. So this app.main, and then the colon is for what we're calling from that module, which is app. And we already defined app as the getApp function. And the reload is, it refreshes for any code changes that we make. So you can leave this server running as we code, and it'll refresh real time. If you succeeded, some messaging, some logging should have come up there and told you that on port 127.0.01 or localhost, you should be able to click that, and you might see something that says, ugh, hello world, or whatever kind of message you left for yourself. All right. Was anyone able to get the message on their browser? A couple of you, yeah. All right, that means we're able to make a hello world script. All right, let's see what our application needs based on what we've done so far. Okay, our application needs configuration, right? We talked about that. We want to add some application settings maybe. We want to initialize that database, and we want to connect to it. And then we want to have some logic. Like, what do we do once we have these pieces running? What can we do with our application? All right, so we're going to put these pieces in little by little. Let's go back to our config.py. And we have a class in our config.py that's called app settings. Notice that before we had ellipses there, or pass. These are settings that will be specific to FastAPI. Like I mentioned, they're not secrets for anyone, so we can define them straight here. There's going to be, and these attributes are specific to FastAPI. FastAPI expects a title, a description, a version, and a docs URL, and several others. If you look at the documentation, it tells you what you can use. Go ahead and type in any title that you care to use for this application, any description that you think suits you, and a version number. I actually, if you let it default, it'll version to 0.0.1. Go ahead and put a different number in there just to see what it does. I think I put 007 or something, 0.0.7. I think you have to use I'm not sure if you have to use the dot notation or not. And the docs URL, that one is an interesting one. I'm just using docs. It defaults to docs, DOCS, but you can put any value there. This is where FastAPI automatic documentation is going to go. So just by virtue of creating a FastAPI application, you already have documentation, really cool documentation too, and we're going to see that in a minute. So if you type something in here other than DOCS, when you're testing on your end, just remember that, where your docs are located, and you'll be able to see that. And then what we're going to do, once you have those values, go into your global settings, and I'm creating a variable here called more settings. This helps me, and it's not totally necessary, but this makes sure that whenever we call our settings variable from any place in our application, if you were to do settings dot more settings, it's going to return those values that we just defined as a Pydantic base model. It'll make more sense when you see it. So let's go back to our main.py file, and we're going to import those settings from the bottom of our, or the ones we defined in our config.py. Mind you, if some of you still have a print statement in your config.py, you might see it pop up every time you're refreshing. It's fine, or you can take it out if it's still there. So now we are going to call those app settings that we just talked about. Notice how I'm referring to them with settings.more_settings.dict parentheses. So this is giving us a dictionary of the values we defined as application settings, right? And now that we have those in a dictionary, we're going to unpack those values in our FastAPI app. If you're not familiar with unpacking, the notation is there is 2 asterisk or * app settings. What this does is it takes the values that are contained in that dictionary that we just defined, and it adds them as assignments to this function. So now you have title equals so-and-so, description equals so-and-so, version equals so-and-so. So that's what unpacking looks like. It's a great shorthand. And great. If you go back to your browser and do a /docs or wherever you saved your documentation, you should see something similar to this. Now, I think, yeah, so the title that you gave your application should show up just like that. The title of my application is Goodbye Hello World, and the description, you can barely see, but you have it right there as a functional FastAPI web app. And you'll notice that there's this interesting little get here. We'll talk a little bit more about this in a minute. So we're already taking shape. This is what's really cool about this automatic documentation, is that if you're building something like an API, you don't even have to build some like mock index.html and try to create some sort of front end that you can test your API. You already have access to that in the back end, and we'll see that in a minute, how that would function. All right, the next thing is the database connection. So we're going to revisit this. Let's go back to db_config, and we're not changing much here. We're actually only adding one line that's going to help us decipher that nothing went wrong. We're going to add a print statement. Usually you would add a logger statement here or a logger function here. We're just going to use a print statement. After we await init_Beanie, we're going to, and outside of the parentheses and everything, we're just going to say, hey, nothing went wrong. So that means we're connected to our database. And that part we already know. So we should already have this variable down at the bottom of our db_config. Let's go back to our main.py and import that variable. So we're going to do from app.db.db_config import db, and that's our instance of that database connector. And what we want to do with this application is every time we start it up, we want to connect to our database. So FastAPI has this neat thing called add event handler. When you add an event handler, you can tell it on startup, and that's the string there, startup, do this thing. And since the variable db that we imported is an instance of our database connector class, we're going to access the method that we defined called initialize_db. And that's all we have to do. So on app startup, our application is going to connect to our database. And if you've done everything right, you might see a unicorn when you, if you were to run your unicorn command, you might see that it's telling you that you are connected to a database. And it should tell you to which database. So if you used the .env values that we talked about earlier, you'll notice that we're connected to the dev dark star database. If you were to change your .env value, your application would need to know about it. What I like to do is just disconnect. To disconnect, you can press Control-C, I think, and it disconnects from the server. And then you run your unicorn command. And if you've changed that end state value to PRD, then when you connect, it'll actually show connected to Darkstar, which should be our production. All right. So we've handled the application configuration, we've handled the database connection, and there's a final piece, which, if any of you are familiar with this sport, is this person is doing a really good job at running his route. Now, what is a route? Most of you, if you're here, are already kind of familiar with that terminology. A route handles a client request, and that's what someone outside of your application is sending a request to your application. It does some complex thing, so this client says, okay, I want X, Y, and Z. Your application takes their request and says, okay, I'm going to do all this stuff based on that request, and then it's going to create a response based on that complex thing. And I really like that just very straightforward 3 points there when thinking about routes. They can get super complex and you can get lost in the weeds. Be very focused about what you want your application to accomplish. If you are a user of your application, what is it specifically that you would want it to do? Let's say you have a database of all your favorite songs. Well, I want it to If I were to send a request to my application of all the songs by Pinback, or all the albums by Pinback, I would need to know what request to send, so maybe a query of Pinback. Okay, my application gets that string value, now what? The complex thing is, take that value, perform a database operation, get all the values, and present it in a specific way. It might be a dictionary, it might be a web page, but you've done the complex thing. So those are the things I wanted to emphasize. There are different things that a client might do, different actions. Some of the ones you may have heard of are get, post, put, and delete. These are common HTTP methods. So a client might send a get request. They just want to get something. Or they might want to post something to your database, or put something there. Slight differences between those. Or they might actually have the ability to delete something from there. There's other methods that are less popular: options, head, patch, trace. These are a little bit beyond the scope of this, but FastAPI can handle any of these operations. A route, some of you may have heard of it as a path. Some of you may have heard of it as an endpoint. In essence, it's the same idea. You have a URL, example/pinback/Loro. The path would just be pinback/Loro. So depending on what is in that entire endpoint or route or, the path, then your application might need to know what to do. Now, FastAPI recognizes some of these verbs through different decorators, route decorators. That we saw an example of the app.get. You'll see app.post, app.put, app.delete. These decorators, you put them in front of your function, and your function performs the complex action. I like to think of my routes as looking like something like this. App.get, we define a function. Let's do a complex thing. I get a result from that complex thing. And you'll see there that I'm assigning to that result a complex action. This is a really, really good pattern to take with your routes, because a lot of people like to write their logic into their routes. So you'll have this route for get, and you'll have tons of lines of code here in your route. And it can make it very difficult to find, once you start scrolling, you might have a lot of routes and you don't know where to start. Whereas if you were specific with what this route is doing and what that complex action is, you can put that complex action elsewhere in your code and know exactly how to go to it when you need to, access it. So there's different reasons you want to follow this pattern. You can keep your routes very thin and readable. It makes it easier to be explicit about what you're doing. It might not just be do one complex thing. It might be a step of things, but it's very explicit with what you're performing with that route. And maybe someone who's not as experienced with Python might look at the route and at least understand what it's supposed to do before they dig into more complex code. And it also allows you to stay organized, which I think it's a service to your future self. So again, an app response. The third thing the app response is, after you've done that complex thing, is you want to return something to the user. And this is straight from the FastAPI documentation. When you create a FastAPI fast operation, you can return pretty much any sort of data from it: a dictionary, a list, a pedantic model. Now, FastAPI by default encodes, if it can, it encodes the response into a JSON. It uses a JSONable encoder to return something. So if the result of your complex thing is a dictionary, FastAPI will automatically convert that as a JSON response, which is really cool. You don't have to even say JSONify or anything like that. It will just send it as a JSON response. It does the same thing for a pydantic model. So for example, we created some models. If you're returning a database model that we created as is, it'll JSONify it right then and there. You don't have to do any additional coding, which I think is really great. Now, you'll notice that my website, my blog, is it really a web application? There's things that it does. I can log into it. I can create, I as a user can create articles from within its own interface and updates and different things like that. So in that sense, it is. I'm the only user of it right now. But I created it in a way to take advantage of the dynamic nature of a web application. So you could pretty much create your own CMS if that were your thing. And to do that, though, you're not just dealing with JSON data. You're having to do some extra stuff. Of course, if you're using a front-end framework, some React or any other JavaScript framework, you already have the JSON data that you can feed to that front end. I don't know any JavaScript, so I just used HTML and CSS, and I used a template response from within FastAPI that uses Jinja templates. So you'll see that you can use different template classes from within FastAPI. If you're using an HTML response, it'll convert any text into an HTML. So in this case, you're returning a string that will be converted to HTML. And there are different kinds of FastAPI responses. So you have JSON response, which is, again, the default, but you can tell it that you want to send an HTML response. You can do a redirect response, which will know to send a user somewhere else if they land at a certain endpoint. There's file response, streaming response, plain text response, a lot of flexibility with what FastAPI can provide. So again, you're not just limited to the API in FastAPI. There's other things you can do. You can stream content. You can provide files and other services. So that's why it's a very great framework for pretty much anything. So now we're going to follow the Rube Goldberg machine of what we've been building. We're going to kind of finish off looking at how to build a database interaction and fit in with all these pieces. So let's go ahead and create 2 new files. Under CRUD, we're going to create another favs.py. And under routes, we're going to create a favs.py. Now you'll note that there is potential for name collision when you're using the same module name that exists in different directories. I like to be explicit when I'm calling methods from different modules, so it's often not a problem for me, and it helps me stay organized. Any logic that I'm applying to my favs.py model, I'm going to put it in my CRUD favs.py operation. Same, and any routes that deal with that specific piece, same thing. So for me, it actually helps me stay organized. For you, you may want to name things differently. It's up to you. So we're going to do a complex thing. We're going to go to our CRUD favs.py, and we're going to import our favorite song DB and our favorite song create models from the models directory. And you'll see how I had to be explicit here about where it's coming from models.favs, and I'm importing favorite song DB, favorite song create. If you use relative paths here, like dot notation, that's where having name collision could occur depending on how you're naming things. But again, I'm always explicit with the root directory in all my import statements. And then once you have those import statements, we're going to create this operation. So, I'm missing an import. No, I'm not. This is correct. So I'm going to create a function that's called getMyFavoriteSong, getFavSong. And you'll notice that as a parameter, it's just going to take a string value. I call it song. And it's pretty easy to look in the database to try to find it. because this is an async function, async def, we're going to use an await Beanie method. So favorite song DB, again, that's the object document, the object document that we created with Beanie. That object document has a method called findOne. And there are different ways of writing the parameters. Here we're just using dot notation. We're looking at the favorite song DB class, and the dot song title is what we're looking for. And we're looking for the exact value of the song that we passed to this function. If not fav_song, this is just saying if there's no value, then we're just going to return a generic message that the song was not found. Simple enough. However, if we do find something, we're just going to return that value as a dictionary. I did tell you that you could just return fav_song and it'll still return the same thing. Here I'm just showing kind of a different way of doing it. So that's one function. The next function we're going to create is called, I think I just stepped through these, create favorite song. So it's this, for creating a song, we're going to pass 3 parameters: song title, artist, and description. And you'll notice that song title and artist, they have stir type hints with no values associated. So that'll mean that both of those will be required fields by Beanie. The description is optional though, so if you don't want to put a description, that's fine. And then what we're going to do is we're going to create this new favorite song and we're going to save it to the database. So you'll see the fav_song that we're assigning favorite song create. So this will create this Pydantic class with song title that matches our song title, artist, description, description. I think, let me do it this way. So again, this is the equivalent of a document, if you remember the mental model there. And what we want to do is we want to just save this to the database. That's all we're going to do. To save this to the database, remember what I said before is our favorite song DB is our document model. And what we're going to do is we're going to unpack, we saw unpacking earlier, the favorite song.dict that we just defined, and we're going to save it. And this will save to our database with those values. However, we do want to make sure we give a response to the user, because we could just leave it there, but the user would not know what's going on. So I just go ahead and return the favorite song. That'll let them know that, hey, this was returned. Now, this isn't really what you'd want to do ordinarily, because if the save to the database failed, you'd still be returning the values that they provided you. Ordinarily, if you wanted to ensure that they're getting the values, you'd probably run another find to the database what they just submitted, and then that'll ensure that you're giving them an accurate representation. But for now, this is just for demo. Cool. So now, yes, question?
Should that method return the favorite song keeping through the model rather than the
Say again?
that create that song method? Should that return favorite song instead of favorite song instead with the Pydantic model?
Yeah, so this line here is returning a Pydantic model. It has nothing to do with Beanie. So this was the way that we ensure, usually you have the model that defines, because remember, favorite song create, I think it says pass, but we're inheriting from the one that defines the variables or the attributes. Line 18. Oh yes, so this is very true. So you're asking about the return value, the type hint. So the return value here we're saying is favorite song DB, and you're right. It should technically just be favorite song create, because that is what this is here. That's correct. I think I created this when I was creating another find operation after this, where I'm finding from favorite song DB. But again, that's one of the ones I just kind of must have cut out there. But you're correct. Now this won't give you an error. This type hint won't give you an error if you run it, if you left favorite song DB up there. But that was a good call out. So now we're going to go, hold on. Yes, now we're going to go to our routes folder, our routes directory, and we're going to pull up favs.py. And there's a couple things I want to point out here. We're going to call specifically the CRUD operations that we just created, get favorite song and create favorite song. We're also going to pull, we're also going to pull the models. And the reason we're pulling the models is actually only for type hinting. I don't even think you need them here. And this, the one on line 4 is really important. You'll notice when we created a hello world script, we did an app.get. That's because in the main.py we have an instance of app. However, we're creating these routes somewhere else, and we don't have an app instance in this file yet, in this module. So FastAPI provides this thing called API router. It kind of functions a little bit like the app. We define a variable called router, or it could be anything, but it's commonplace to use router, that is an instance of this API router. So now we can use it in the same way that we were using app before. So instead of using app.get, now we can use @router.get, and we can define some endpoints. What's neat with FastAPI is you see the curly braces there on the path operation. That means that FastAPI will take whatever value is put in that endpoint, and then it will use that value, which we're defining as an attribute in our song retrieval function. So again, the route is /song, whatever that song is that the user types in, async denf, which is the function we're creating, and then return, and this is skipping a step. We could just assign that get favorite songs and then return that value, but this is condensing. Await get favorite song. And you'll see that that's the complex thing. So this route is pretty straightforward. Like, you know what's happening. People who who are newer to coding might understand what's happening here and maybe not what's in the back-end logic, right? That's why we kind of separate things. And then we do the same with the favorite song create. Now, this is interesting. What this is saying is this endpoint, add song, is where a user might go to add a song. But how would they do that? There's different ways you can do this with FastAPI. You can create query parameters. I know sometimes you've seen ampersands and q equals in different URLs. That's usually what they're for. In this case, it would actually be an endpoint that another API would send a post message to. And because we've defined what it's looking for here in our function, it's going to expect values that fit that model, that favorite song create model. And that's all we need to do. Now if API, someone else's API sends invalid data, it's going to fail. And we're going to be able to send the reason that it failed. Hey, you didn't send the required field song title or artist, or it's invalid data because it's not a string. Now, one thing Pydantic will do is it does try to coerce value. So if someone sent the number 32, it would try to coerce that value as a string value, which again is a really amazing Pydantic thing. So those are the routes we've created. And now we can go back to our main.py. And we're actually going to take this route here. I don't like it in main.py. I'm just going to take it out and put it in our favs.py. I like to keep my main.py tidy. So if you want to just cut this out and include it in your favs.py, ordinarily you might put it somewhere else, but let's just include all our routes in the same py file for now, favs.py. And then if we go back to our main file, we're going to import that router from our routes.favs. I don't know why there's a space over there under 4, but it should work. So now this allows FastAPI to access those routes we've defined under routes, under the favs.py, under the routes directory. That's all we need to do there. And then we need to include that router into our app. So you'll see an app.include_router, and you pass it the router. That is a FastAPI method, just shorthand for allowing us to include routers. So if you actually had routes that lived in different modules, you just want to make sure that they're included here under include router. And that's what our useful FastAPI web app looks like. So let's go ahead and see if the project runs. Is anyone connected to, is anyone connected? You're connected? All right, so what I expect to see is something like, give me a second. Oh, now here we go. Just a moment. I'm not able to connect. All right, let me try this one. There we go. Oh, all right, let me see if I can. So there's my ugh, hello world, right? If I go to the docs, you'll notice I used version 0.07, it should match what was in my application settings, right? And what's really cool with FastAPI is all of a sudden I have these cool ways to test our endpoints. So you'll notice that these descriptions here actually match the documentation, the doc strings that you would have put under those documents. So that's pretty useful. And you'll notice if you go here, there's this button called Try It Out. If you try it out, it gives you the ability to type in a song. Let's say I want to find a song called Boo. I can execute that code, and it'll tell me, message, Boo not found. And that is the error message I wanted to find. Now, if I wanted to go ahead and create a song, this allows me to test the API right from my documentation. I don't have to open up Postman or any other way to send a post message to my API. I can test it right here. You go under Try It Out, and you'll notice that the documentation shows the request body that it's expecting based on the model that we built, the Pydantic model. So the song title is going to be Boo. The artist, pinback. The description will be a great song. And then if I hit execute, you'll notice that the response is here. It shows you what the curl is, where the request URL is, and it'll give you the response body. So I know that I was returning the same thing. But now, if I go back to test the song that failed earlier, if I go up here and execute again, you'll notice that the response is right here. And I know this is in my database because now there's an ID, and this is the object ID that is saved into my Atlas database. So I now have the ability to write any kind of create, read, update, delete functionality straight into my database. I know that I'm in my, well, actually now I'm in my production database, and I know I'm in my production database because when I started up my, oops, that's too big. Oh, now I've lost it. It didn't like that. It told me what, I'm connected to Darkstar, that's what it says. And I know that's my production database. So I know based on my connection where I am, I can see the response body here when I go to find. And all the create, read, update, delete methods are with Beanie. If you go to the Beanie documentation, it's all there. And then you can do a lot of cool things. Like you can get a list of everything that is in your database, do different types of operations. And I am sadly out of time. I do feel like we got most of the way there. Let me go back to, I keep losing my mouse on this thing. Did I lose it? Oh, that was that same. There we go. I think I can close it. With FastAPI, you will be using type hints a lot. Learn them and fall in love with them. They're really great, especially with the way that you use Pydantic. Async is really easy to use. I didn't even talk about it, but you kind of saw it. You create an async function, you await it. It's really great with database operations. So if you have a lot of stuff going on with your database, it's built right into this system. And the FastAPI documentation is awesome. So I didn't spend a lot of time with FastAPI, but you actually don't need a lot of time with FastAPI. With what you have now, you can focus on the actual logic of what you're looking to present. And I'm just going to fly by a couple now what's, things that you can think about. And again, this will be here with the slides, and I'll have a couple resources later. A couple random tricks that I would talk about is caching. With FastAPI, you can use LRU_cache. What that does is, instead of just returning the settings variable, you can cache it. So each time that you're accessing your settings variable in your application, you're not loading those environment variables again. You just use the cache, and I think that's a super great feature, easy to implement. So instead of using settings like that, you define get app settings and you return that very same thing, and now you have a cached version of your settings. Makes your application quicker. This talks about LRU cache, and this is how you would do it. I would, instead of importing settings, now we're importing that function get app settings. Then in our application, we're creating a variable of settings from get app settings, which is cached. Now, when you're in development and you're going from testing a lot of different things, you may not want a cached version, because say you change some environment variables and you're trying to refresh things. That's why I include a cache clear. So when I'm in development, I just include that there at the top, and you can comment it out or take it out when you're actually in production. Logging, I would highly recommend. I learned how to use the rich library. If you don't know about rich library, oh man, that's such a great library. It has it basically creates really beautiful looking console messages on your terminal. It also has a handler for logging called rich handler. I took that rich handler and I configured my own way of looking at my logs that I liked. And then I just went ahead and returned the rich handler to the configuration for the logging. And then there's this really long, annoying thing you kind of have to do. Uvicorn has a lot of root loggers to it. So I cycled through all the loggers that are already in place for the application. I got rid of them and then inserted the rich handler. And now I have really nice logging messages when I'm working in my application. That's something else you could do. These things might really help. And then again, what I do is I create a file or a module called rich log. I import that thing that you just saw, and I set up rich logger at the top of my application. Linting, keep your code beautiful. It really helps. I didn't understand this when I first started. You look at Flake8, Pylint, MyPy, Black, and all these things that make your code more readable. It's a favor to yourself, it's a favor to others, but mostly to yourself. You'll pat yourself on the back from that. If you look at a wall of text, it just looks annoying to read. This is just from my English background. I don't like reading that. But if I split it up in paragraphs, that looks a lot more, it's way easier to read. It's the same thing with code. You want to just think about how it's spaced, think about how it looks. It's just as important as what it's actually doing. When we talked about building our application, you might have thought, what are some other things I could do? Well, my core directory might include that rich log.py, or it might include a module for security that's specific to the security of my application. It might include custom exceptions. I think those are really great to let you know what's going on in your application. I talked about how I like to name my models and my CRUD operations, the modules the same name. For me, it helps me know how the data relates, and it helps me keep it separate as well. If I know something's wrong with my users, for example, I know exactly where to look. I don't have to look through a models.py and try to scroll and find comments. Oh, this model is for my users. So I keep all my things separate as possible. My routes, they can maybe be a little more generic, but I also like to know what they're doing. You could put all your routes in one file and just put it into your application, but I think that makes it harder to find what you're looking for. So in this case, I have a home.py that would handle like entry point type stuff, a home page, about, contact, if it's applicable. I have a music.py that might be related to both songs and artists. So instead of having a song.py and artist.py, maybe I want to include those together. and user.py maybe only user data exists or user routes that are specific to them. And then if you do APIs, you want to version your APIs anytime you make changes, especially if you're coming back or people are using your API, you want to let them know which version to use. So this is a way to do it. In your app directory, create an API directory and then keep versions of that in there. And then within those versions, then you can create your routes. That'll just, you know, as your applications might get more complex, that might be it. But yeah, the world is yours. The web application is yours. I am super happy that I got to share what I could share, and I wish I could share a whole lot more, but I really wanted to open up. I don't think we have much time for questions, but you can find me right outside at the end here. And most of all, thank you for coming. I really appreciate it. I'm super excited.